Hello everybody, my name is Amisha Chauhan and this video is a demonstration of the project Fabric Eye, Fabric Defect Detection and Classification for the Textile Industry. India is the world's second largest textile exporter, yet walking to any small vendor shed and quality control is still one person. One pair of eyes scanning meter and meter of cloth. I visited a textile unit during a school excursion and watched exactly this. And that image never left me. Enterprise AI solutions exist, but they cost lakhs. They need heavy hardware and were built for factories. So small vendors are completely left out. That's the problem Fabric AI solves. Let me walk you through the two models at the heart of this. The first is UNet. I trained this from scratch and as always did the data pre-processing where the major steps were to rename the masks and also create missing masks. So the unit basically takes a fabric image and produces a pixel level map of exactly where the defect is and calculates what percentage of the fabric surface is affected. Here you can see the architecture. It compresses the image down to understand the big picture. The second model I used is CNN-based classifier trained on fabric defect images. Instead of building a very large model, I used a relatively lightweight architecture suitable for running on standard hardware, thread pull, or a good fabric. And lastly, for the deployment in the Streamlit app, both models load at the startup, as shown here. The webcam captures images directly in the browser. The pipeline runs the unit model first. And only if a defect is detected. Based on a threshold, logic helps reduce the unnecessary classification on a clean fabric. Let me now show you the system running. I have opened the app and this is running locally on a standard laptop with no GPU required. I will capture a fabric sample through the webcam. You can see the original image on the left and on the right, the segmentation overlay showing exactly where the defect is highlighted. Below that, the defect type, that is the hole, the affected area, over here it's 0.41%, and the system decision of defect detected. At the same time, the system sends a signal to an Arduino module. When a defect is detected, the Arduino receives the signal and turns on an LED indicating a faulty fabric piece. Over here, this orange light indicates the LED. This demonstrates how the system can be extended from just analysis to real-world action. This entire interaction takes only a few seconds, no complex setup, no specialized hardware, and it runs directly on a standard system.